In this session, we'll discuss different types of bonding. So there are different types of bonding. Basically, there are four main types of bonding, but you are studying only three of them. One is known as ionic. The second one is known as covalent. And the third one is known as metallic. We'll discuss in detail about the three types of bonding. So what is ionic? How you will identify whether a bond will be ionic, covalent or metallic? If a compound consists of, or a substance consists of metal and non-metal. So if you have a metal and a non-metal, then it will have ionic bonding. What is ionic bonding? That we will discuss later in this session. But if you have a metal and non-metal mixed together, combined together, that we call they have ionic bonding. What is covalent? If non-metals, two or more non-metals are together, they will have covalent bonding. And metallic, within the metal, or you have an alloy mixture of the metal, then it will have metallic bonding. So these are the three main types of bonding. One is known as ionic, another one is known as covalent, and the third one is known as metallic. Example, if I say sodium chloride, NaCl. So what kind of bonding is there in sodium chloride or NaCl? So you will check the type of the element. When you check sodium, sodium belongs to group 1, and we can use a periodic table. So you can see a periodic table here on your screen. So sodium is there, which is Na group 1. So it is a metal. And chloride, chlorine, group 7, it is a non-metal. So when metal and non-metal are together, one of the element is a metal and another one is a non-metal, then what kind of bonding or what kind of attraction they will have? We call this type of bonding as ionic. But if two or more non-metals are together, like example, we have carbon. How Na is the metal? You can see, Abdullah, as I told, if you remember, I mentioned how to work out the position that metal and non-metal. So you have the periodic table here. You will draw a staircase line. So elements on the left hand side all are metals and an element on the right hand side are non-metal. So you can see here, you can see that sodium is on the left hand side, so it is a metal. Chlorine is there on the right hand side, so it is a non-metal. So metal and non-metal are together. So what kind of bonding they have? They have ionic bonding. Another example, if I say carbon dioxide. Carbon dioxide, so when you check the position of carbon and oxygen, when you check the position, the carbon is on the right hand side. This is a staircase line. And oxygen is also on the right hand side. So both of them are non-metals. So when two or more non-metals are together, so carbon is a non-metal, oxygen is also a non-metal. So when two or more non-metals are together, what kind of bonding they have? They will have a covalent bond. And within the metal or a mixture of metal, example, if I say Fe, iron, alone as iron, what kind of bonding it will have? So when you check the iron, iron is a metal. So when metal is alone, what we call this bonding, we call that as metallic bonding. Is it clear how you can identify the type of the bonding? If it is metal and non-metal, it will be ionic. If non-metals are there or alone non-metal, it will be covalent. And if metal alone or a mixture of the metal, then it will be metallic. Yeah, metal plus non-metal is ionic. Non-metal and non-metals, it will be covalent. And metal alone, it will be, or mixture of the metal, then it will be metallic. So example, if I say what kind of bonding is there, this is a staircase line. So example, if this is a staircase line, what kind of bonding is there within copper alone? Copper is Cu. The three types of bonding are ionic, covalent, or metallic. So what kind of bonding is there within the copper metal? Is it ionic, covalent, or metallic? So because copper alone is there, so what kind of bonding it will have? It will be a metallic bond. Same thing, if I say what kind of bonding is there in potassium oxide, K2O. Potassium oxide contain potassium and oxygen. It contains one metal and another non-metal. So it will be ionic, that's right. And what kind of bonding is there in sulfur dioxide, SO2? Ionic, covalent, or metallic? Sulfur dioxide, we have sulfur and oxygen. So as you can see, two non-metals are there, so they will have covalent bond. And what kind of bonding is there in hydrogen fluoride? Hydrogen is a non-metal. Its position is not fixed, but it is a non-metal. HF, hydrogen fluoride. Ionic, covalent, or metallic? Hydrogen is a non-metal. Fluorine. Hydrogen is a non-metal. And fluorine, when you check fluorine, fluorine is also a non-metal. So when two non-metals are together, what kind of bonding is there? So when two non-metals are together, they will have a covalent bond. Same thing, if I say calcium chloride, CaCl2, what kind of bonding is there in calcium chloride? Calcium chloride. So when you check calcium, calcium is a metal, and check chlorine is a non-metal. So metal and non-metal are together, so they will have ionic bond. Magnesium alone, inside magnesium, Mg, what kind of bonding is there? Because it's a metal, so it will be a metallic. how we are supposed to find the bonding in each element. You have to check if it is a metal, as I mentioned here in the beginning. If it's a metal and non-metal are mixed together, like one element is a metal, another one is a non-metal, then it will be ionic. If it is non-metal together, then it will be covalent, and if it is only metal, then it will be metallic. About the bonding in metalloid, it can have different types of bonding, so we are skipping the metalloid part. It may have multiple, like sometime ionic, sometime covalent, because they have the characteristic of both metals and non-metals. So we are only discussing pure metals, pure non-metals, and metal and non-metal together, not about the metalloid. Is it clear, Simon, that how we are supposed to find the bonding in each element? If it is metal and non-metal together, it will be ionic. If non-metals are there, then it will be covalent, and if it is metal alone, then it will be metallic. Another example. So what kind of bonding is there in beryllium fluoride, BeF2? BeF2, beryllium fluoride. So we have beryllium and we have fluorine. What kind of bonding they have? So because it's a metal and non-metal together, so when the non-metal and non-metal together, it will be ionic bond. Same thing, silicon oxide. Silicon oxide, like we have silicon and we have oxygen. What kind of bonding? Silicon is there. If it is on the right hand side, when you're predicting the type of the bonding, you will consider the thing on the right hand side as non-metal, and on the left hand side you will consider them as metal. So you will not consider, like you will avoid metalloid. So you'll consider they are non-metals, all which are on the left hand side, and all which are on the right hand side are metals. So when you check silicon and oxygen, so silicon is on the side of the non-metal, and oxygen is also on the side of the non-metal. So when two non-metals are together, what kind of bonding they have? Two non-metals together. So they will have a covalent bond. Same way, if I say carbon, only carbon, C. So what kind of bonding will be there? Carbon, a non-metal. So when we are predicting the structures like geometry, the type of the bonding, we are skipping the metalloids. We are just considering them. On the right hand side, we are considering non-metals. On the left hand side, we are considering as metal. So when you check the carbon, so carbon is on the non-metal side. So within the non-metal, what kind of bonding it will have? It will have covalent bond. If I say bromine, Br2, what kind of bonding is there inside bromine? When you check, bromine is on the right hand side. So what kind of bonding it will have? On the right hand side. On the right hand side, we have non-metal. So when we have non-metal alone, they will have covalent bond. Non-metal non-metal together, they have covalent. If we have element alone such as chromium, Cr, what kind of bonding is there in chromium? Inside chromium, when magnesium is mixed with sodium, it will be an alloy, mixture of the metal, and alloys will also have metallic bonding. Like example, if I say I have a mixture of magnesium and sodium, then this will be alloy, mixture of the metal. So mixture of the metal will also have metallic bonding. So metal, non-metal, ionic, non-metals alone, or non-metals, different non-metals together, covalent, and metal alone or metal together, they will have metallic bonding. Is it clear the type of the bonding? Then we'll discuss how these bonds are formed, but the first part is you should be able to identify the type of the bonding. So I'm writing some formulas at the bottom. For ionic, write I. You can use the screen annotation. For ionic, write I, letter I. For covalent, write letter C. And for metallic, write letter M in front of that compound. So first one is NH3. You have to identify the type of the bonding. The second one is Mg. The third one is MgCl2. Fourth one is CH4. Fifth one is calcium oxide. Then we have O2, oxygen. Then we have Fe, iron. And the last one is HCl2. So ammonia, because when you check ammonia, this is a staircase. So nitrogen is there and hydrogen. Both are non-metals, so covalent. That's right. Magnesium alone as a metal, so it will be metallic. Magnesium chloride. Magnesium is there and chlorine, metal and non-metal, ionic. Carbon and hydrogen. Carbon is on the non-metal side. Hydrogen is also a non-metal. Calcium oxide. Calcium is a metal. Oxygen is a non-metal. So it will be ionic. Oxygen alone, a non-metal, covalent. Iron, metal, metallic. And sulfur chloride. Sulfur, when you check, sulfur is a non-metal. Chlorine is also on the non-metal. So what kind of bonding it will have? Two non-metals are together, sulfur and chlorine. So when two or more non-metals are there, they will have covalent bonding. Is it clear to everyone that how we can work out the type of the bonding within the substance? If metal and non-metal, ionic. If non-metals, covalent. And if metal alone, it will be metallic, or a mixture of the metal will also be metallic. Then formation of the ionic bond. So today we'll discuss how ions and ionic bonds are formed between a metal and a non-metal. So as we know that ionic bond is formed between the metal and the non-metal, but how this bond is formed? Example, we have a compound sodium chloride. So A sodium chloride, sodium is a metal and chlorine is a non-metal. So if one is a metal, one of the element is a metal and another one is a non-metal, so what kind of bonding it will have? A metal and a non-metal, so it will be an ionic bonding. But how this ionic bond is formed? In exam, they normally ask to draw the structure of sodium chloride. So first what we do, the first step, we will write a formula for sodium chloride. That is the first thing. Now how to write a formula for sodium chloride? If you remember, first we write the symbol. Sodium symbol is Na and chlorine symbol is Cl. Sodium belongs to group 1. So what will be the charge of group 1? So that is plus 1. And chlorine belongs to group 7. So group 7, that is minus 1. So sodium chloride formula, one is plus 1, another one is minus 1. So sodium chloride formula will be, we simplify the valency and cross multiply. So the formula of sodium chloride is NaCl. So first thing, our first step is writing a formula for sodium chloride, which is NaCl. Then how to show that how this is formed? Now we'll draw the structure to show the formation of ionic bond. Basically, the formation of ionic bond means the ions are formed during the bonding. So first we'll draw the structure of sodium. So how to draw the structure of sodium? This is the nucleus of a sodium. I'm writing Na. We have 11 protons or 11 and 11 electrons. So we'll draw the first shell. First shell, sodium will have 2 electrons. Then we draw the second shell. Second shell, maximum it can have 8. So till now we completed 10. And then we'll draw the third shell. After drawing the third shell maximum can have 8 or 18, but we are only left with 1. So this is a structure of sodium atom. Then we draw the structure of chloride atom, the chlorine atom. So this is chlorine. Again, we'll draw the first shell. The first shell, chlorine will have 2 electrons. The second shell, it will have 8 electrons. And third shell, because it is 17, we have to arrange 17 electrons here as we are drawing the structure of chlorine atom. So it is having 17 protons and 17 electrons. So the third shell, it will have 7. So these are the structure of sodium atom and chlorine atom. Now what happened in an ionic bond? Metal, what is the tendency of the metal? The metal will lose its electron or we can say valence shell electron. And what happened? The non-metal will gain electron to complete octet. The term octet means 8. So non-metal will gain electron and it will complete octet. So basically what happened? This sodium, how many electrons are there in the last shell? Because metal will lose its valence shell electron. Valence shell electron means electrons which are there in the last shell. So when sodium will lose its electron, that electron will jump to chlorine. and chlorine will gain that electron and complete octet. Octet means 8. So this electron actually jumps from sodium to chlorine. So when the sodium will lose electron, what will be the charge on the sodium? When the metal lose one electron, so what will be the charge? It will be positive. And when the chlorine gain electron, it gain electron, now it is having extra electron. So what will be the charge on this chlorine? The charge on the chlorine will be negative or -1. So now what happened? The sodium turned into sodium ion and the chlorine turned into chloride ion, and the attraction between, like there is a sodium ion, now a sodium ion is formed and a chloride ion is formed. So the attraction between these ions is known as ionic bond. So basically when metal will lose electron, how we will know how many electrons we have to transfer for the metal? Abdullah, for metals, you have to transfer all of the last shell electron. Example, sodium should lose all of its last shell electrons. So in the last shell, it is having only one. So it should lose only one. And for non-metal, example, chlorine is there. How many electrons it should gain? It should gain electron to complete octet. Octet means 8. So 7 are already there. 1, 2, 3, 4, 5, 6, 7 electrons are already there in the last shell. So it will take only 1 electron. So metal, you should remove all of the electron from the last shell. And for non-metal, you should complete octet. Is it clear? I'll give another example as well. We don't have to transfer 8 electron. We have to transfer electron so that it become octet. Octet means 8 electron in the last shell. So 7 electrons are already there in chlorine. You can see 1, 2, 3, 4, 5, 6 and 7. So to complete octet, this chlorine only need 1. Na is not having 2 electrons in the last shell. Na is having 1 electron in the last shell. As you can see, this is the 1 electron which sodium is having in the last shell. Yeah, if any element was having 2 electron in the last shell, then it will transfer 2 electrons to the other side. I will give another example so you will understand as well. Is it clear? The first one, formation of sodium chloride. Another example, yeah, non-metal should complete the last shell. Last shell means it should have 8 electrons in the last shell. So example, look, I will repeat. We were drawing the structure of sodium chloride. So the formula for sodium chloride is NaCl. So if the formula is NaCl, we have to draw one sodium and one chlorine. So we draw one sodium. Using a periodic table, you can draw the electron because the first shell, it is having 2 electrons. The second shell is having 8 electrons. And the third shell, it is having only 1 electron. So 1 electron is there in the last shell. Then for chlorine, there are 17 electrons. So first shell, there are 2. Second shell, there are 8. And the third shell, there are 7. So first shell there are 2 electrons, second shell there are 8 electrons, and the third shell there are 7 electrons. So for a metal, I told metal will lose its all last shell electron. So as the metal will lose its valence shell electrons, so how many electrons sodium should lose? Because it is having only 1 electron in the last shell, in this example Na will lose 1 electron. And what about chlorine? A non-metal will gain electron to complete octet. Octet means 8. In this example, Cl is already having 7 electron. So Cl need only 1 electron to complete octet. Octet means 8. So basically what happened, this electron which is there with sodium will jump to chlorine. So when this electron jumps from sodium to chlorine, now this electron jumps from sodium to chlorine, so it is no more there with sodium, it is now with chlorine. So when it is with chlorine, now what is the charge on the sodium? Because it loses 1 electron, so it will be plus 1, and chlorine gain 1 electron, so it will be minus 1. And the attraction between the charges, attraction between these ions, what we call this attraction between the positive and the negative ion, we call this attraction as ionic bond. Is it clear? Anyone having a doubt? Yes, Abdullah?
Yes, sir. You said that a metal should transfer all the electrons in the last shell. For
Yes.
example, Na is having two electrons,
Now,
and
in
if
this,
we will
Na
transfer,
cannot have two. Na belongs to group 1, so it will always have 1 electron. It's a fixed number for Na. If any other element is there, then it will have a different formula. But in case of
for
sodium,
example, there is an element in place of Na which is having two electrons in the
right,
last shell. So
right,
it's and non-metal should complete the last shell. If we will
yeah.
transfer both of them, it will make another shell. So we should transfer more so it can complete that 16th third shell.
No, but what happened instead? I will give that example. I got your question. In that case, it will have two non-metals atom. It's not necessary only one. It may have 2 or 3 non-metal atoms. I'll give you that example as well. I got your question. Like what you're saying if it was having 2 electrons, then it will transfer 1 electron to one non-metal and the second electron to another non-metal. Is it clear? This example, I will give more examples. So another example, if we are drawing for calcium chloride. So if we are drawing for calcium chloride, first we should write a formula for calcium chloride. So calcium is group 2 plus 2 and chlorine is group 7 minus 1. So the formula of calcium chloride is CaCl2. So what does it mean? To draw the ionic structure, we have to draw one calcium and two chloride. So we'll draw one calcium. Calcium is having 20 electrons, so it is 2, 8, 8, and 2. First shell it will have 2 electron. Second shell it will have 8 electron. Third shell it will also have 8 electrons. And the last shell it will have 2 electrons. And for chlorine, now we have to draw 2 chloride. So this is one and this is the second one. The first one and second. First shell it will have 2, second shell it will have 8, and third shell it will have 7. This will also have 2 8 and 7. So the cross to represent the chloride electrons. First shell 2, second shell 8, and third shell it will have 7. Now what will happen? I told metal will lose both of its electron. So this calcium will lose 2 electron. But what happened to complete the octet? This chlorine already having 7. So it can only take 1. So one of the electron from calcium is taken by one chlorine and the second electron is taken by another chlorine. So this electron, one transferred to one chlorine atom and the second electron transferred to the second chlorine atom. So what will be the charge on this calcium? Because this calcium loses 2 electrons. So as it lost 2 electrons, the charge on calcium will be plus 2 and each chlorine take 1 electron. So the charge will be minus 1. So metal is losing its last shell electron and the non-metal is gaining electron to complete octet or 8 electron in the outermost shell. So that's why when calcium react with chlorine, it needs one calcium atom and it needs two chlorine atoms. Is it clear, this example? The formation of calcium chloride. Yes, Abdullah?
So, for example, Cl was not having plus two. What will happen?
Cl cannot have plus 2, it can have minus only.
No, like
Ca,
in
Ca is
like
plus,
you write the chemical formula.
yeah.
Then
Calcium,
what?
calcium is plus 2 and because it belongs to group 2, it's plus 2. Chlorine belongs to group 7, so it is minus 1. So when we simplify and cross multiply, the formula of calcium chloride is CaCl2. So we should have one calcium and two chlorine to form a bond with each other. So whenever we are writing or drawing a structure, first we should write a chemical formula and then we will draw, like, because according to the structure in the previous example, sodium chloride was having one sodium and one chlorine. But in calcium chloride, it is having one calcium and two chlorine. So we have to draw one calcium and two chlorine atoms. And then we have to show the electron transfer. The metal will lose all of its electron and the non-metal will gain electron to complete its octet. Is it clear, this example? I'll give another example related to this formation of ionic bond. So basically the attraction between these ions, like the positive ions are attracting the negative ions. So when these positive and negative ions are attracting each other, we call that bond as ionic bond. I'll share another link and continue this discussion of ionic bonding.